More probability coming your way. All right, 16-4 probability problem. Solve the combinations. We're going to do a lot of examples with cards, some probabilities of poker hands. Maybe you can win some money off whoever you're quarantined with. Let's get right after it. Okay, just a little reminder about what combinations are because we're going to use them extensively in this chapter. Okay, remember these are when order is not important. That distinguishes them from the permutations. Here's kind of the formula. I'm usually going to write it in this format here, this NCK format. So for example, if you have like 8 items, you're trying to choose 3, 8C3. A lot of times people also write this as in this format. Okay, both are equally valid. Okay, the other main important thing that we need to know for this section here is just the standard formula for that theoretical probability. All right, we're going to be using these combinations, and we're going to be using those desired outcomes over total outcomes again and again. So let's just jump into some examples here. The first one, 5 cards are drawn at random from a standard deck. Find the probability that all 5 cards are hearts. Okay, so this is one where you can actually do without using the combinations. So I'll show you that way first. It's going to be very similar to how we were doing kind of those probability problems without replacement. So getting the first heart, all right, so there's 13 hearts in the deck, 52 cards. Okay, and then if you're drawing without replacement to get the next heart, there's 12 hearts left, 51, etc. And then you would just use the multiplication rule. Multiply all the way down, and that would give you the probability that all 5 cards are hearts. And if you plug that in your calculator, you would get about 0.000495 will be the probability of getting all 5 hearts. So let's kind of try this using combinations. So we've kind of danced around this idea a little bit and done it a bit. So I'm going to think of this more as kind of that theoretical probability, desired outcomes over total outcomes. So thinking in my denominator, all right, so if we have 52 total cards, how many ways are there to draw 5 cards? That's just going to be 52, choose 5. Okay? And the numerator, all right, well, we have 13 hearts. We want to choose 5 of them. So the number of ways to choose those 5 hearts from a total of 13 is that 13 choose 5. This is just matching up with my desired outcomes over total outcomes. If I throw that in my calculator, I get the same exact value that I got up there. Okay, so that's how we can use those combinations to our advantage, because those give us the total number of outcomes, all right, for both desired and total. We can use that to find these probabilities. All right, so here's another example, very similar to the first. But instead of that all 5 are hearts, we need exactly 2 are hearts. So it makes it a little less realistic to use that first method that we did in the last slide, where we're just kind of multiplying down the row. The issue is we don't know when these hearts are going to appear. They could be the first 2 cards, they could be the last 2 cards, they could be anything in the middle. All right, so we would have to figure out each kind of arrangement separately and then add up all those probabilities. It's going to be a major headache. So we're strictly just going to use the combination method here. We're going to start in our denominator the same way. Number of total outcomes still going to be 52, choose 5. 52 total cards in a deck. We want to choose 5 of them. All right. Now, so what we need in our 5 cards, we need 2 hearts and 3 non-hearts. Okay, it's very easy to forget about the 3 non-hearts here. All right, but they're going to be an important part of our 5-card hand. So let's kind of think about first for the 2 hearts. Well, I know there are 13 of each suit, so there's 13 hearts. We want to choose 2 of them. All right, and then for the non-hearts, all right, we eliminate all those hearts. There's 39 cards. We want to choose, well, not 13. I said 39, then wrote 13. So 39 non-hearts, we want to choose 3 of them. And there it is, okay? This first part, that's choosing the hearts. This second part, that's choosing the non-hearts. We throw that all in the calculator, you get about 0.274. Okay. So, just a little reference point here for if you've never played poker before, it's not a problem. These are just fun combinations to figure out these probabilities. You could probably figure out what these things in the bottom mean: 3 of a kind, 2 pair, 1 pair. A straight is 5 cards of any suit in sequential order. Okay. A flush, 5 cards of the same suit, any order. Full house, 3 of one card, 2 of another. 4 of a kind, self-explanatory. A straight flush is a combination of straight and flush, hence the name. So they need to be all in rank order, but also all the same suit. And then the royal flush, okay, is they need to be all the same order, all the same suit, and they also have to be the highest rank. So it's always got to be 10, Jack, Queen, King, Ace. So we're going to figure out kind of the probability of getting some of these hands. Knowing the order from best to worst is not important here, but knowing what I mean by each of these kind of different hands is important. So just put this slide here for reference. Let's jump into some examples. So find the probability of getting a full house. All right, so if you remember, the full house is 3 of one rank, 2 of another. Okay, so an example would be, let's say we'd have, here's our 5 cards. If we had 8, 8, 8, 3, 3. Suit does not matter at all. Okay, so we just need basically a 3 of a kind and a pair. So we can start in the denominator again. 5-card hand, we know there's going to be 52, choose 5 ways to do it. So that is a fantastic starting point. All right. So I'm going to kind of use the same strategies I was using for that last one. So what we need to do is we need to choose basically the rank. All right. Then we need to choose which of those cards from that rank. And then we need to choose the rank for the pair, and we need to choose which 2 of those cards for that. So let's kind of start with the 3 of the kind. All right. So there's 13 total suits, and we want to choose 1 of them, okay, for our 3 of a kind. And I'll just annotate. So this is the rank for the triple. And then once we've chosen that rank, so we chose like 8, now we need to choose, there's 4 of each of those. We only want 3 of them. So there's 4. You gotta choose 3. Okay, so we chose the rank for the triple, and then we chose which 3 of those 4 possible cards. All right, so now we gotta deal with the pair. Okay, we handled the triple. Let's work with the pair. So in order to choose for the rank for the pair, it cannot be the same rank as that triple. So we only have 12 options now. And we just want to choose one again. All right, and then we know there's going to be 4 total cards. We want to choose 2 of them because we want the pair. So there we go. All right, so it's the rank for triple, choosing the 3 cards, the rank for the pair, choosing the pair, divided by the total number of 5 card hands. All right, so my numerator, you multiply that out, it's like 3,744 over 2 million something for 52, choose 5. I think it's 2.7 million, something like that. We're going to get quite a small number here. Approximately that. So there's the probability of getting a full house. All right, so let's do another poker hand here. Probability of getting a 3 of a kind. All right, so this one's more self-explanatory, but I'll draw out some cards again. So we need a triple. And then we need 2 other cards. Okay, so those 2 other cards are quite important. Can't leave those off. And it's also important that those 2 other cards are not the same. Okay, because if they were the same, then you'd be getting a full house. If those 2 last cards were 5 and 5, you would have a full house and not a 3 of a kind. So we need to make sure we distinguish between those 2. So I'm going to start again with that 52, choose 5. All right, so let's kind of work through. So I'm going to do kind of the same setup. All right, let's choose the rank for our 3 of a kind. So we know there's 13. I'm going to choose 1. And that's my rank for the triple. All right, and then I want to choose 3 of those cards, 3 of the possible 4. So 4, choose 3. Okay. So now I got to move on. That handles the triple part. So now we need to move on to these 2 singles. Okay, there's 12 remaining. I want to choose 2 of them. Okay, 2 different suits. Okay. Or sorry, 2 different ranks. All right, so this is the ranks for the singles. And then for each of those 2 cards, all right, there's 4 options. I want to choose 1 for both. So this is choosing the first single, be 4, choose 1. And the second one, also 4, choose 1. So the total of my numerator is 54,912 divided by that 52, choose 5. You get 0.0211285. Obviously, I could have rounded that a little bit closer, but either way, quite a small number. All right, last example in the interest of keeping this video somewhat short, and I'm sure everyone's tired of cards, so let's do something different. We got 4 balls are chosen at random from a bag containing 4 white balls, 3 green balls, and 5 black balls. Find the probability of choosing 2 white balls and 2 black balls. All right, great. So this is going to be very actually similar to the card thing. We know we have, what, 4 plus 3 plus 5. So we have 12 total. And we're choosing 4. Okay, so that means our denominator is just going to be 12, choose 4. All right, it's the total number of ways to choose 4 balls from this bag. All right, up top, so we need to figure out, we want to choose exactly 2 white balls, 2 black balls. All right, so there are 4 white, we want to choose 2 of them. So that's 4, choose 2. There are 5 black, we want to choose 2 of them. So 4, choose 2, times 5, choose 2. There's no other balls we need to worry about, just like it's not like the one we just did with the cards where we had to choose those singles as well, because we've handled all of them. All right, we picked our 4 balls. We picked the 2 white and the 2 black. So this is for the 2 white, this is for the 2 black. So multiplying that out with the calculator, you'll get 0.121. All right, that's all, folks.